This is a video to show you how to do problem 9.15, which tells us that we're going to consider a null hypothesis that the mean is 72 versus the alternative hypothesis that the mean is bigger than 72. So this problem is just getting us to practice before we apply it to a story. So let's say we have a random sample of 16 observations, and we also have a population that's normally distributed with a standard deviation equal to 6. So if the population is normally distributed, we don't have to worry about the fact that we have a small sample below 30. So the first part is going to tell us that we're going to calculate the p-value. So p-value comes from first calculating z-test, which is x bar minus mu over sigma over square root of n. Let's see. Oh, I missed a piece here. It tells us that our sample mean was 75.2. So we're going to plug in 75.2 minus 75. Remember, this comes from the hypothesis. And then we're going to divide by standard deviation of 6 over the square root of 16. And when we do that, we're going to get 2.13 as our z-test. So in order to make p-value, we have to look at, here's our z distribution with z is 2.13. And then the p-value is associated with the tail, the tails that match the alternative hypothesis. So alternative hypothesis had a greater than, so the p-value is the tail that goes with z-test, and the size of this tail can be found from looking it up in the normal distribution table, and we can see that it comes from 1 minus 0.9834, so it's going to be 0.0166. This is our p-value. In words, that means the probability of getting our sample or one further to the right if the null hypothesis had been correct that the mean was equal to 72. Okay, part B asks us to consider the p-value in part A. Would you reject the null hypothesis if the test were a significance level of 1%? So when significance level is 1%, what we have to do is compare p-value to significance. So if p-value is less than alpha, then that means since 0.0166, here is our p-value, that is bigger than 1.01. So we'll reject if p-value is less, but p-value turns out to be greater, so we do not reject the null. Part C asks us, would you reject the null if the p-value, if the level of significance was 0.025 or 2.5%? So in that case, p-value is not unchanged because that has nothing to do with level of significance. It has to do with where the data landed. And we already did that from z-test. So p-value is 0.0166 is smaller than 0.025, our level of significance. So yes, reject the null hypothesis. So alpha, our level of significance, remember, is how stringent a criteria that we want to set. And since we relaxed the criteria on part C, it was easier to reject the null. When we had a very high standard to meet, we did not reject the null on part B.